This is the Mikoyan MiG-35, a fighter that promises incredible capabilities on paper. But there is one problem. The Russian military has less than a dozen of them, and it looks like they may not get any more. So why is this cutting-edge machine gathering dust when it could be changing the tide of the war in Ukraine? And can Russia afford to let it slip away? Designed to close the capability gap between older third-generation fighters like the legendary Mikoyan MiG-29 and Russia's own fifth-generation stealth platform, the Sukhoi Su-57, the Mikoyan MiG-35 is Russia's definitive 4++ generation evolution of the Cold War-era jet. It aims to deliver multi-role dominance in highly contested airspace where advanced avionics, powerful engines and super-maneuverable aerodynamics meet heavy payload capacity and long range engagement prowess. The MiG-35 boasts an impressive combination of attributes that make it a formidable force on the battlefield. One of the standout features of the MiG-35 is its use of naval aviation lessons learned from the carrier-based Mikoyan MiG-29K or Knight and Cub variants to enhance its design. The result is a heavily modified airframe that's lighter and more capable than its predecessor. Incorporating 17% more composite materials and radar-absorbent coatings, the MiG-35's airframe is optimized for high angles of attack, allowing it to sustain extreme G-forces during combat. The fighter's enlarged leading-edge root extensions or lurks further enhance its maneuverability and allow it to perform sustained high-alpha maneuvers with reduced drag. These design features give the MiG-35 exceptional air-to-air capabilities, enabling it to engage multiple opponents simultaneously and emerge victorious even against stealthy fifth-generation adversaries. Equipped with 9 wet hardpoints, the MiG-35 carries a substantial payload of up to 6,500 kilograms of ordnance. For air-to-air engagements, it utilizes R-771 or Vesti active radar homing missiles with a range of 110 kilometers. These missiles are specifically designed to engage enemy aircraft beyond visual range where stealth becomes less effective. Additionally, the MiG-35 can employ shorter-range infrared heat-seeking missiles such as the Vimpel or 7.4 RVV-4 within visual range dogfights. To enhance its ground attack capabilities, the fighter carries guided and unguided bombs, including the advanced KH-38 and modular glide bombs which leverage real-time targeting data to adjust their trajectory mid-flight and strike moving targets with precision. For maritime missions, the MiG-35 can carry the KH-35U anti-ship cruise missiles which utilize a combination of satellite navigation and radar-absorbing materials to evade enemy defenses and deliver powerful payload to naval vessels. The power plant driving the MiG-35's performance is a pair of smokeless Saturn AL-33MK afterburning turbofan engines, each generating 19,840 pounds of force thrust. These engines propel the fighter to a top speed of Mach 2.25 or over 2,600 km per hour, ensuring rapid deployment and swift engagement of enemy threats. Furthermore, the RD-33MKs enhance the fighter's vertical performance, enabling a remarkable 330 m/s climb rate, allowing the aircraft to quickly gain altitude and dominate the airspace. The combination of the RD-33MK engines and the aerodynamic improvements results in exceptional handling characteristics, including 9G turn rates that defy conventional fighter aircraft. These features underscore the MiG-35's status as a technological marvel and a potent force multiplier on the battlefield. Originally, the project included 3D thrust vectoring nozzles on both engines. However, due to production cost and technological complexity concerns, these were cancelled for the production model. Despite this, the MiG-35 still retains many advanced features, including its ability to supercruise at Mach 1.6 without afterburners, reducing its infrared signature and improving fuel efficiency. The fighter also features an integrated sensor fusion system that enhances situational awareness by combining data from various sources including the JK active electronically scanned array, or AESA radar infrared search and track or IRST sensors, and onboard data link. This advanced sensor fusion significantly improves the pilot's ability to detect, track and engage multiple targets in a cluttered battlefield environment. Speaking of the radar, The high-end JK produced by the Vega Radio Engineering Corporation boasts an impressive range of 160 kilometers. With its ability to scan 160 kilometers ahead, the JK can effectively detect, classify and track up to 30 airborne targets simultaneously, including stealth aircraft with a cross-section as small as 0.5 square meters. This advanced radar system allows the MiG-35 to maintain a comprehensive view of the airspace, ensuring early detection and engagement of potential threats. Furthermore, the JK's tracking capabilities extend to engaging 6 targets at once, providing the pilot with the necessary information to make informed tactical decisions and execute air-to-air maneuvers with precision. Complementing the JK radar is the OLS-35 IRST system developed by the company Infrared Systems. This cutting-edge IRST offers passive detection capabilities extending beyond 50 kilometers, making it invaluable for identifying stealth aircraft like the American F-22 Raptor or F-35 Lightning. By leveraging the passive detection capabilities of the OLS-35 IRST, the MiG-35 can effectively identify and track stealth aircraft such as the F-22 or F-35 beyond their usual detection range. This capability significantly enhances the fighter's air-to-air capabilities, allowing it to engage stealth platforms that rely on low observability for their tactical advantage. However, the OLS-35 IRST's applications extend beyond stealth detection. It also incorporates a built-in TV channel with the ability to continuously scan the horizon, a feature absent in the older and simpler OLS-5 used by the 4th-generation Sukhoi Su-27 and Su-30 families. This continuous scanning capability enables the OLS-35 IRST to monitor vast areas of interest, providing the pilot with a comprehensive view of the surrounding airspace. It enhances the fighter's overall situational awareness, allowing for the early detection of aerial threats or potential targets. Crucially, the OLS-35 IRST is slave to the SAP S-35 electronic warfare suite, forming a robust sensor fusion system that ensures accurate target identification and engagement. This level of integration enhances the effectiveness of the MiG-35's air-to-air and air-to-ground capabilities, allowing the pilot to engage multiple targets simultaneously across diverse mission profiles. The cockpit of the MiG-35 reflects the cutting-edge advancements in fighter design, featuring a glass canopy that offers panoramic visibility, and houses 3 large 15-inch multifunctional displays or MFDs, each measuring 15 inches. These MFDs, powered by an integrated Shukran 35 digital fly-by-wire flight control and avionics system, provide a high level of situational awareness, presenting critical flight data, sensor information, and weapon status in a user-friendly interface. Notably, the MFI-35 incorporates AI-assisted threat prioritization, enabling the pilot to focus on the most critical threats in high-intensity combat scenarios. Additionally, a helmet-mounted sight coupled with an integrated infrared search and track or IRST further enhances the pilot's ability to detect and track targets, allowing for precise off-bore sight missile locks and improved air-to-air combat capabilities. But perhaps the most important aspect of the MiG-35's capabilities lies in its sensor fusion architecture. By integrating data from various sensors including the JK active electronically scanned radar infrared search and track or IRST, and onboard data links, the fighter presents a comprehensive and accurate representation of the battle space to the pilot. This integration enables the pilot to seamlessly switch between air superiority and siege or suppression of enemy air defenses missions in minutes. For instance, if the initial sortie involves engaging enemy fighters, the pilot can transition to hunting down and destroying surface-to-air missile sites or siege with just a few button clicks. This flexibility stems from the MiG-35's onboard computing power, which enables real-time data processing and fusion, providing an accurate and up-to-date depiction of the threat environment. Equipped with data links such as the Russian-made L-band secure data link, the MiG-35 can receive targeting data from other friendly aircraft or ground stations. This capability enables the fighter to share critical information about enemy positions and engage targets with greater precision. Furthermore, the L-band data link ensures secure and encrypted communication, safeguarding sensitive information from interception or jamming by enemy forces. In Ukraine, however, the MiG-35 is deployed only in very limited numbers and mostly in rare air defense or standoff strike roles, conducting operations far from the front lines. This approach helps to mitigate risks to Russia's small operational fleet of MiG-35s while still allowing them to contribute to the war effort. In these missions, the MiG-35 leverages its advanced sensor fusion and data link capabilities to engage enemy targets while maintaining a safe distance from the front lines. For instance, the fighter can utilize its onboard data links to receive targeting information from ground stations or other aircraft, and then engage enemy positions with precision-guided munitions. This standoff capability reduces the risk of the valuable MiG-35s being lost due to enemy fire or engaging Ukrainian fighters head-on. Additionally, the fighter's advanced sensor fusion system enables it to integrate data from various sources, including its onboard radar and IRSD, as well as external inputs such as targeting data from ground stations or other aircraft. This comprehensive view of the battlefield allows the pilot to make informed decisions and engage targets with greater accuracy. Despite its impressive capabilities, the MiG-35 faces significant challenges, including limited production numbers, a lack of internal weapon bays, no all-aspect stealth coatings, and international sanctions that have curtailed its export prospects. These factors have hindered the fighter's ability to fulfill its intended role in Russia's military arsenal. As a result, the MiG-35 has received mixed reviews, with some experts praising its advanced technologies while others criticize its production shortfalls and industrial-based challenges. The fighter's future remains uncertain as Russia grapples with balancing competing defense priorities amidst political tensions and economic constraints. There's a big problem with this plane. It's incredibly expensive, costing between $45 and $50 million. While it undercuts the $64 million F-16 Block 70 and the $115 million Rafale, it's still far from what Russia needs, especially since it lacks the stealth and advanced sensor fusion capabilities that define fifth-generation fighters. In terms of network-centric warfare, the US and NATO allies dominate with their advanced data links like Link 16. These enable seamless information sharing and coordinated attacks, something the MiG-35 cannot match. Consequently, the fighter lacks the situational awareness and collaborative capabilities that are crucial for success in modern warfare. So the bottom line is this: the Mikoyan MiG-35 represents a significant leap forward in Russian fighter technology, boasting advanced sensor fusion, powerful engines, heavy payload capacity, and long-range engagement prowess. However, its full potential remains untapped due to limited production numbers, a lack of internal weapon bays, no all-aspect stealth coatings, and international sanctions that have hindered its export prospects. The fighter's future now hangs in the balance as Russia confronts difficult choices regarding its defense investments amid political tensions and economic constraints. Will Russia double down on the Su-30OSM and Su-35S, or will it bet big on the unproven yet innovative Su-70 Okhotnik stealth drone along with its fifth-generation checkmate? Or maybe the Kremlin will keep the MiG-35 around until a viable replacement emerges from one of these programs. Only time will tell. And before you go, make sure to check out this video next.